Alright. So, today is the 23rd. Yes, I was jamming out to David Brothers. Stuck in my head. Rad was up on the TV. So, we are taking our work with parabolas and extending it to circles. So, everyone's going to need a graphing calculator.
I got one for you yesterday.
Oh, life is so hard. I got one for you yesterday.
Yeah, it's a pact. I get one for her, she gets one for me, or
We
you
called
get one
it
for me.
in college, we had what we called the community, which was like, I buy dinner tonight, you buy dinner the next time, whatever, like that whole sort
No,
of
that
thing.
wasn't
Wait,
typed
are we
because
getting
I pressed down.
What used to
I'm
do?
gonna type that.
Oh, we have a
Yes,
test
semester.
Oh, that you can't figure that out.
Oh, my shoes.
We'll come back to that at the end of this.
He's gonna.
But you could probably figure that out on your own, like without us doing it. But we'll come back to that.
But everyone failed.
I just don't want to take the time to get to the file right now because my computer's been real slow lately. So I want you guys, because this takes a bit of critical thinking, we are going to take a little bit of time on the warm-up today. So in your backyard, let's hypothesize, imagine, whatever you want to say for a moment. You have a perfectly square backyard. It's 80 feet by 80 feet. And you have decided that this summer you are going to install a water feature involving a circular pond in the middle and a circular feeder pond. Now, this is actually what people do because they will have like a koi pond or something like that, and they'll actually have a breeding pond or like a smaller pond off to the side, or maybe that one's got the fountain or whatever. So you need to figure out what the radius of each of these ponds is going to be. The only thing you know is that your yard is 80 feet by 80 feet. How that?
Wait, this is what you do.
Oh, this looks nice.
Not difficult, but you gotta kind of turn on your brain a little bit.
What do you got to find?
I don't even know.
I don't even have a brain.
Caleb, you're fired.
What did I do?
Caleb, you're fired.
It was.
Is there another set of
Brian did
notes
it.
somewhere?
Brian took the
Ah.
job for who? So fire him.
Yeah, but it was assigned to you.
And he stole it from me.
Well, if it was your job,
I'm not gonna fire
even
him.
if somebody else does it wrong, it was assigned to you.
That's the
Caleb,
only
you're
thing.
fired.
That's a little worse.
That sucks.
Come on. Okay. You're trying to find the radius of each of those ponds.
How could you find the one of the little ones?
The little one?
I like how Caleb started by saying, "Is this supposed to be hard?"
Oh, wasn't the problem with this one? I can
Yeah. Right?
Yeah.
We could.
Oh,
This
I
is a
thought
fun
we were
problem.
just finding the big
That was the only one we couldn't figure
I
out.
thought we were just finding the big one. That's why I
Both
thought
of
it would be hard.
I don't think
solve
that because you don't know any of the
dimensions.
Yeah, you do.
prohibit
Big one.
80 feet.
Use your mouth.
Diagonals are 80 feet. Yeah.
The diagonals are not 80 feet. The diagonal would be longer.
No, but there's no relationship between the 80 feet and the little one.
Oh, yeah, there is.
Well, there's gotta
Doesn't
be.
say anything.
So, if this is
Oh,
a
never mind. I'm stupid.
Stop. Getting mad doesn't make you right. Remember, logical fallacies. And being louder doesn't make you
Those are
right.
40.
So we know these distances are the same, right? Principal factor of a circle, those are the same distances. If this is a square, and we know that this distance is the same, and that's inscribed in a square, and the square is inscribed in another square,
Oh, okay, I missed.
what relationship could we start to build to take towards finding out information about the circle? Michelle?
Well, you know that the smaller square, the diagonals are 80 feet.
So this, if I go the rest of the way, and the rest of the way, that's 80 feet.
Yeah, and then you take half of that, and that would be, like, if you draw the other diagonal, you make triangles, and then you take half of the 80, and then the legs of each of the triangles are 40.
See it piece together now?
There is.
Yeah, you're really worked up, man.
No, I misread the problem. So I thought the round pad was 80 feet. Oh, so that's what I thought. I was like, this seems.
No, your yard was 80 by 80.
Oh, I thought you meant like the yard is like.
That was the only thing we knew.
Okay.
Except that this somehow is perfectly dead, perfectly circular. You like put something there all winter, like that literally. If you like in a board, it's laid down on grass all winter, like a piece of plywood. Your grass is dead, like it is gone. So then, should I even keep going or pass it off? All right.
Keep going. Okay, so then you know that there are isosceles triangles, and the formula to get the hypotenuse of an isosceles triangle is times radical 2.
What time radical 2?
The length.
So we're saying that this hypotenuse is going to be 40 radical 2, which radical 2 is like 1.4. So that's going to come out to be a little over 60. What do we get?
56.
56
And a half.
56 and a half.
Is that exactly? No.
Close enough. Or what comes after the 5?
685.
Let's do 5, 7 then. Because there is a decent amount of accuracy difference between tenths and hundredths as we go to convert back to like if we wanted to do inches at the end. And then, what does that distance actually give you, Megan?
It gives you the diameter of the big circle.
So that gave us that is 56.57. Cut that in half to get the radius. And that would be
28.285.
28.285 feet. Now still though, we need to get the small bond.
It's the same problem. It's the same. Well, like that. The same as the one they could do.
What? The same as the one we couldn't do?
The math counts.
Yeah, it's the same.
This was the one problem on team round that we couldn't figure
Wait,
out.
really?
Yes.
No,
That
That's
finding the
exact
area of.
I have not seen the competition materials. Like those don't come to me till April.
Yeah.
So this was okay. So wait, finding the area, or what was it asking you to do?
The area of the triangle that wasn't
It
the
was
circle.
the
Yeah.
difference. Yeah, it was the difference.
Okay, so let's talk about how we're gonna figure out the pieces of the triangle. So to deal with this corner, you know this now, right? Because it's a square, so we know that's our 56.57. So
2 days would be 40.
how do you know?
Because the whole thing's 80, so cut in half is 40.
This can just transfer over, and these are both 40. So actually, depending on what the dimensions were with the problem that you guys had, any of these triangles now end up having a base and height of 40 and 40.
Yeah.
Michelle?
Like split down the middle of the triangle and make another isosceles triangle where 40 is the hypotenuse.
Like that down the middle? Okay. Because this now pairs.
Where's that? There's that one.
Yeah, there is a segment up here though.
Yeah.
So have you taken that into consideration?
Yeah, I don't know how to do it.
Okay.
Can you solve for that little tiny triangle?
Poor child.
But that's not a triangle. It's a problem because the
Did
bottom's
you do
curved.
something area?
So,
How do
like
you know-
Calvin was saying, at math counts they had a problem where it was saying what is the area of the triangle not in
The circle.
the circle. Oh, so like this, the
No, like
triangular.
if you take the corner part off,
Yeah,
the green part, the area of the green part.
yeah, okay. But that's not what we're actually looking at here. We need to figure out the radius of the circle. If we were just trying to find the area of the green part, we could find that. We got it. Base and height, 40, 40.
No, but like where the circle isn't.
Are you talking about the brown sections?
No, in the
Oh, here.
yeah,
Oh, all you gotta do is find the whole area of the triangle, then take away the area of the circle, so we do need the radius.
right.
So still the question remains, how do we find this?
It looks like it's. You can't say it. Doesn't mean
Wait,
it's
can
true.
you do the? Could you go back to like the circle unit and like find
No,
what is it called? Sector, is that what it's called? Like circles.
How would we? We don't really know any other information about the circle.
No,
Well, it's 90 degrees.
Oh, wait.
Oh,
Does the circle inscribed
wait,
in
no,
triangle
never mind.
are the three things?
Yeah,
that
they're
it touches?
we
those
tried
Could you
that.
split
Those
it
trisected?
into a certain amount of
These parts are
triangles,
equal.
so that like
But that doesn't
the
No,
thing
like,
that goes
if you
altitude,
draw
is that what it's called, of one of the triangles, is
that
the radius,
with that trisected?
and then you can solve for.
Do you know that? Like, is
I
this
want to keep that.
Well,
and get rid of that.
these are this is
So actually, if I get rid of this too.
Wait, was that right?
I forget.
So hold on. Let's do, I guess.
Wait, I have a question.
Okay.
So theoretically, we already know the segment from from above this circle, the mini circle.
I mean, we know this is 40.
And we know from that point to the red dot down.
We're trying to find this.
No. I'm saying we know from the top corner to the red dot
Do we?
because it's
You can find
square,
Okay.
and so we would know it's 28.285.
Oh.
So we don't have to figure that out, correct? Right?
So are you saying that
I thought we already
this-
established this. I'm sorry, no?
Are you saying that this is the distance you're talking about?
Yes.
And that's 28.285.
How does that help them?
Okay, I don't know, but I thought we already said that. Sorry.
So that's the question, is that helpful? Because that involves an extra little segment there
No, yeah.
that we don't want.
Yeah, they just force that.
Are you able to, I have like,
Still have to land the land.
okay. Quick question, are you gonna make this into one of the problems where it's like the answer requires a formula you're about to teach us?
No.
Okay. So
Can
I
we
hate
just say
that
that? You
kind
said
Well,
that
here-
with
here's
like
some
six
ideas.
Guys, why don't we just read the key concepts?
You've got everything in front of you. But if I go back to Dr. Smith's class at Ottoman, he would just start drawing lines. So if I'm looking for radius,
Was he your favorite teacher?
he was. I may go back to Ottoman because of that.
Heck
He wrote the Masters in Math Education program. So I've got two radii
triangle.
that could be right there.
But how do we know the rays or the segments for the 90-degree angle hit the parts where the circle touches the?
We can assume that because the circles are inscribed in the square, there's no wasted space. So we can assume that where the circle hits, that this is tangent to it, and there is a radius length here that creates perpendicular.
Oh, okay, yeah.
Because we're inscribed, we just have to make kind of those assumptions that where it hits is tangent. So that's tangent.
Yeah.
I have a quick question
Yep.
about the math here. So, question, that little dot thing right there, so do you know how Carmen said that one line between the red dot and the edge? Does that dot in the middle be the halfway point, or am I just making an assumption?
This,
No, the dot in the little pond thing.
What?
The midpoint of the
This.
circle.
Yeah,
yeah,
was
that we're making the midpoint because we said these are
But that
radii.
would not be the midpoint
Try
of
the
the
center.
whole thing because of that little bit of
Okay.
grass.
It's the midpoint of the circle plus the segment versus the other side.
The issue is this green corner.
Give it to your neighbors.
Because these are.
So guys, again, when we talk about the whole choice between like honors and not,
This
this is where like
and so
an
this
honor
is-
student
if this is
wants
1
to
unit
figure out
versus
this
radical
problem.
2 units, so then 1. So
A
then
non-honor
1
is
plus
saying light it
radical
on fire.
And then since you know the entire thing,
Huh?
this
Who is
is
that?
20
So-
radical 2.
So like really, when you set up your attitude for like how am I approaching this?
Like,
So you
I
guys are
told
sitting
you
here
the
cracking
answer,
jokes
total
about
is this. And
that
then
they're
find
working
this.
really hard. But
So then you can do this over 1 plus
We'll just
radical
make that X.
So I know
Yeah.
that
So-
and this
X plus.
would all be the same lengths.
So X is the radius, right?
Oh,
Kind of
that's
make
a
a cool
kite.
little peace sign.
So
Huh?
then we count it. Did.
It's a case. In the
Right?
left corner with the
Okay,
blue.
but can I
Oh,
use
yeah.
that?
Probably. Let me write that down.
It's not.
Because then-
So you're hypothesizing the
Oh,
kite that is
Wait.
here.
No.
There's
No?
another one in the left corner.
Yeah. Wait.
If you look at it. Here, it's, you know the corner
Or
with
here?
the green dot? Or the
Okay,
other one.
Well, that's
but we don't know this. But we do know that this would be the radius.
Yeah.
Hmm?
This is.
This is why I
Why do
wanted
you
us to take some time with this. This is a fun
Because
problem to
one-
struggle with.
1 plus radical 2 times X is the entire
Okay,
thing.
there's
Wait,
a
you
kite.
can't
X
you
is
solve?
radius.
Because then there's
So it's
triangles.
radius. and
So wait, so hold on,
radius
hold on.
times 2.
Hold on. We got some good knowledge in the room. Hold on.
Why do they have X?
Megan.
Where's the X?
Say what you've been saying. Well, let's see if you can connect it together and figure out where it's going.
This is
Nature
pressure.
amazing.
I know. There's a kite in the
Okay.
corner.
Okay.
And then if you divide it in half, you get 2 triangles, and it's what's half of 40?
Okay, so I'm gonna move this.
Can you like zoom in on that spot and then redraw it?
No, because that would be a lot of redrawing. So you're saying cut it in half.
Yeah.
So I'm actually gonna switch colors.
Do blue.
Wouldn't that make it that?
No, not blue.
Purple.
Some kind of like purple.
X. 2X.
Okay. And then the one angle down in the corner
Oh, wait,
is
no.
28.5 because
But
it's half
isn't-
of 45
isn't it
because it's 22.5.
Minus 2.
Dying.
So then
Okay,
it's
so you're saying you could
Yeah.
know this angle.
That doesn't make any sense.
22.5. You might. Stop being a Debbie Downer.
I got he knows it.
Wait, no.
Okay.
And then you solve because triangles.
But what?
You would need to know something. I agree.
Yeah, that doesn't.
Solve because
Well, that's
triangles. But here's the. So Megan's essentially saying use trig, right?
Yeah.
You'd set up a right triangle. This would make a right angle. Hold
You
on.
could use triangles.
I'm not gonna let you talk until you quit shooting down her approach and we look at if this could work. Because all because yours could work doesn't mean that hers won't work. It's math. There's a lot of right ways to floor it. So hold on. So Megan, what can we say
I was gonna say that.
with that whole relationship? Then you said this angle was 22 and a half.
Yeah.
Okay.
And then you can use. Okay. Wait. No. Wait. Yeah. No. Angles. Just like. Well, you have an angle, and you have an. That's adjacent. Yeah. So you have the adjacent. So you can use. And you're trying to find the opposite. So you can use TOA tangent, and you can do it.
Okay. Tell me what to do.
Okay. So tangent of 22.5 equals.
I love that sign.
Wait, where do we get 22.5? That's the angle.
It's
measured.
half of 45. What's half of 56.75?
When you split it into 2 triangles, it cuts the angle.
We already
in half,
found
so
that.
22.5.
It was 28.
Okay.
Oh,
So
because
28.25 over 28.25.
I saw this time.
And
Right,
then
yeah.
you solve.
Yeah, but you
and
cut it.
it's great.
But no, yeah.
So then you
Right,
multiply
yeah.
each side by 28.25.
So
You
let's
got it.
see, because then we're going to compare some results. 28.25. Exit out. Or 285, sorry. Times the tangent
Good job, Megan.
of
Hurt my
22.5.
brain.
Make sure you're in degrees. If you get a weird answer, you're not in degrees. So according to this method, my radius will be 15.78 if we round feet. Alright, Brian.
Okay, so
That's not.
alright, so
So I guess
we know that side, right? And then that side and that side have to be equal. So then you can just subtract
Whoa.
that.
Slow down.
Use your words.
Alright, so
Or
Can you say
colors.
this or
Use
no?
something.
alright, so you know that this one, we know this length, right? So then we know this length. So then
Why?
we just
Heights.
Well, okay, because it's a kite, yes.
Alright, then you can just subtract
I'm on.
40 minus however long that is.
So,
Minus 20
yeah. Good job.
Oh,
Actually, not gonna lie,
That
that
was
was
a
really
lot
impressive.
so when we set up that
Like
kite,
this thing.
what we see is this side is the kite leg plus a radius. Because that radius is transferable over here. So we've got two different ways, but if we do that, does it come out to be the same result?
I don't know. I didn't do the math.
It would be approximately because there's some rounding
Because-
involved.
There's gonna be some
So
rounding.
this is the 20.
Wait, it was like correct.
And when
No, I
you
really
divide
wanna
it
be
like this, so we have. So if this is
Wasn't
the
this
radius,
28.285, which means that 40 minus 20 would give me like
and then this is
22?
also
I
radius.
didn't
So
study the
radius
math.
plus
I was
factor 2
in
radius
the
is the entire length.
Yes.
And then you can solve radius.
Wait, was my weight
Just do the
incorrect?
Pythagorean. Just do 40 times 40 plus or times 2, and then subtract that stuff. And you get the hypotenuse.
It's
The answer
40
doesn't
minus
add
10
that.
by 2, right?
What do you mean it doesn't
Is that
Well,
not a
this
So
whole
that
length
is also
was 56.57, right? Because that was our 40 radical 2.
20
So half of it's 20 radical 2.
Oh,
Which
So
I
then-
think we found out to be
Yes,
28.285.
20 over
I don't think these come out to be the same
divided
answer.
by 1 plus.
It's
But
56.
then
So,
we don't
alright,
get not a
divide
kite.
it by 2,
is it not a kite?
and
Yeah,
then
it's something different.
Yeah, it has to be a kite.
40. Oh, shoot.
That's how math works.
That's
It's 11.71.
So
yeah, I knew it was going to be about 12 because we're essentially doing 40 minus 28.
11.71.
So that's not the same.
So one of them is
So
wrong.
mine's right.
yeah.
Obvious.
So hold on, our two potentials right now.
What? Or the
11 point what?
11.7.
Oh, that's what I got.
For the
That's
way
what
I
I
got
got.
it.
716.
Yeah, that's what I got.
What did you get?
That's what Max got.
Yeah, I
That's
got.
what I got also.
Hey, copying somebody else doesn't matter.
No, I didn't copy. I told Brian I didn't.
He asked that.
Okay.
Did he
It's like
follow?
more incredible.
That's what that
and
is.
You're like saying
Yeah,
dumb
But
things
he
half the
followed
time.
his methods.
No,
Okay, so hold on. But we need to decide which is right and why.
I don't know.
obviously.
Don't get upset about it.
You're the one who used the calculator, so if it's wrong, it's your fault.
Obviously
Whoa.
not the trig
Just
one.
saying.
The trig one uses trig, and I don't
Why
use
couldn't you trig when you
using trig when I can use it.
How did you find the angle of the kite?
Cause it's half of. Cause that's 45. Cause that's 40. Yeah,
Okay.
angle, and then you
My
divide it by
sausage
2.
triangle has to be 45, 45, 90. She cut it in half.
Why didn't you get it? 'Cause that should have worked too.
So 20. We're saying 22.5 is one of the angles, and then the other angle was.
Maybe it's not a circle. Maybe it's an oval.
No, maybe. No,
I
you
like that
went
theory.
straight away.
It should have. I agree.
But yet it did. Mr. Rosen, you know how.
I blame it's Hudson's calculator.
Yeah, it's
I'm checking my mode. That's seriously what I'm doing right now.
The first time I had it, I got Brian's answer, and then I
Wrong
changed my mode, and I got the other one.
I'm in radians on my calculator. So,
Okay, I did it.
See, I knew.
here's the point of what we just did. I was hoping one of you guys would actually calculate this.
Well, you
Why
did.
did none of you type this in?
Because you
I
did
did
not
not
got
get
to
to
see
see
your
it.
answer.
Because I just trusted
That
your
was
answer.
I have a point to this. It was either last year or 2 years ago. My Math 2 class came back from state testing. We're like about to really ramp up and get ready for state testing. And they were like, there were these questions that like we should have been able to solve. Like we knew how to solve them and our answers didn't make any sense. Like when they took a bathroom break, they did what they should have. And they like talked to each other about the test. Once you're done with the test, obviously you can talk to each other about it. But they're like, this, it just didn't make any sense. They were in radians. Well, actually, they were in degrees, and the problem was being given in radians. That answer of 15 seemed like it could make sense. Right? This is 28. I don't know much about this. That's 40. I don't know. This could maybe be 15. Seems reasonable. And we just went with it. Now, your trig worked. Your method was absolutely correct. But my calculator was in radians. And I got an answer that seemed like it made sense. And if I had blindly taken it, gotten that wrong. So one point of this is if you know different methods, cross-check your work if you have time available. Another huge point is make sure you have radians versus degrees
Wait, how do you
correct in your
change it
calculator.
to?
So, mode to pick these up because we've only worked slightly with these. I want to make sure that as we do more of these, we have these for the rest of the year. So this is what I was hoping somebody would type that in when I did, and I was leaving my answer up there waiting for somebody to say, hey, you made a mistake. Hit mode. Depending on which model you have, your menu will have different amounts of things. Scroll down to where you see radian and degree, whatever's highlighted in black or whatever color you want to say. That's what you're on. So if you're in radians, I did the math, 28.285 times tangent 22.5, it came out to be 15, whatever it was. When I switch it to degrees, all I have to do is hit enter again, and it spits out my new answer of 11.716, the correct one. So actually, ironically, you can get to a point where your calculator shows the same two functions typed in with two different answers. Because one answer was given when it was programmed in radians, and the other was given when it was programmed in degrees. So this is really funny to show people sometimes. They're like, I can get two different answers doing the same thing in my calculator. Because that was like one operating system, and this was a different operating system. Like, really OS is the wrong word, but you guys know what I mean. The selections in your program. Yeah,
How do you know whether to use degrees or radians? Yeah.
so the math that we were plugging into our trig was a degree value. So what that's asking you is when you're plugging in anything involving angles, which mainly is going to be trigonometry for us, are you plugging in a degree measure or are you plugging in a radian measure? We can plug in a radian measure because we have our unit circle. We're going to do more with this. We talked about it a little bit like a couple months ago. But we have a radian conversion for 22.5 degrees, which comes from, if we just review this really quickly, I'll use my pen at. Let's capture this. Does anyone remember in your unit circle, actually let's just use this as our unit circle, how many radians it is to get around the circle once? All the way around. Like how many degree, or not degree, but how many radians of angle it took?
2 pi.
2 pi. So a whole rotation is 2 pi, which means that if all we do is 180 degrees or a half rotation, that distance would be pi radians. If all we do is 90, that distance would be pi over 2, or that angle opening. 45 would be pi over 4, and our angle that we just used would be pi over 8. So if I redo this in my mode of saying radians, and I retype in the same thing, except I use pi over 8, divided by 8, 11.716. Do you want to type it in, or do you just want to take my word for it? So now I've got 3 different functions all typed in, giving me 2 different answers. 2 of them are radian settings, and 1 of them is degree. But now I can use pi over 8 because that's actually what 22.5 degrees is in a radian measure. And just to help this sink in more, we call this the unit circle because it's dealing with whatever your unit is. So actually here, in this pond, we ended up finding that the radius of it was 28.285. So all of these values, these radian measures, would be that times 28.285. Because it's whatever your radius is. That's why it's radians. Is measuring based off your radius. So it is in units of whatever your radius is. So it just copies. Let's get into this lesson a little bit. My goal is to just finish up this lesson by tomorrow.
Oh, this is the last one too.
Yeah, this is the end of the chapter.
Wait a minute. What?
Wait a minute.
We're ready to move on. What'd you find, dude?
Let me process through it for a second. You can move on.
Or are you still thinking about that math counts problem?
No.
Got us,
If we had just drawn a whole bunch more lines, that would explain this
You can.
I'm curious though. Can you
What-
formalize it? or
I
do you
thought
think
I
of it?
found a much easier way to figure it out.
Oh, there could be another route. I don't guarantee that's the only one, but the kite and the trig are the two. Well, obviously the trig uses the kite, but those are the two methods that are kind of
Mine's
easiest.
pretty easy.
Yeah.
It didn't involve much calculating.
And actually, funny enough, like I am preferential to the trig.
I don't know. It's
Like-
much like
I
wood
like-
and it's
I
like
like
wood.
it.
But I don't
It's pretty
think
easy.
the calculator does the thinking.
Oh yeah, yeah.
But that's the dangerous thing.
Oh
about
yeah, I
radios
don't like
versus
this.
these.
I don't know if it's gonna mess up or not.
Okay, so what? Did you find another method or not?
Yeah.
I know there's a lot. Which one are you looking at?
Should I?
You can come up if you want. I plan on taking some time on this.
Okay.
Good circle work and stuff like this. Let me zoom. This is why I love when we can do problems that I just ask you guys to guide me, because it's funny to see which route we end up taking.
Oh yeah.
Dang, gave even all.
Yeah, your lines aren't quite straight. But
Yeah, but.
Yeah, you guys see what he's saying?
David did that.
So how? So you still need to start by making a jump and figuring out some.
If you know the radius, you know that this is the same length.
As what? So that's the radius of your big circle, right?
Yeah.
How do you know it's the same?
Because we can just transfer. Well, actually, yeah, that is a really good question. How do you know that? You're assuming that the center of your small circle is the edge of your large circle, which I'm not saying it isn't, but how do you know that?
Just put your triangle. Because. No. Shapes. Yes.
Yeah, when you describe it,
Because shapes, yes.
Just.
You want to play with this a little bit more tonight? And, like we can just bring it back up tomorrow.
You just flip my triangle.
So if we want to cheat a tiny bit,
Oh wait, Emma, go, go, go.
if we want to cheat a little bit, we can use a straight line tool.
but I couldn't use a straight line.
Dude.
You didn't say you could. You didn't ask him.
Because Goose doesn't look a bird.
So
right,
really,
yeah.
we need to find the center of our circle first. Or I guess we could start right here.
It's annoying that
Cheeks, okay. Cheeks. What is on the TV?
So that's perfectly vertical. Shift it a tiny bit off the center. This will come out to be perfectly horizontal. If we try to do this,
You got it.
so then still though, there's a jump that needs to be made. Because we still have only one piece of information. So if you guys want to keep playing with this tonight, what we really have is this we could call R1 because it's the radius of your larger circle. And that we could call R2 because it's the radius of the smaller circle. My black lines go too far, so ignore how far out the black lines actually go. So I'd have a triangle that's
Oh, that's easy.
R1, R1, and then I have that distance of R2. R1 plus R2 would equal your 40.
So 40 minus R1 is R2. Theoretically.
So that, I don't want to take too much more time on this today, because we want to cover a little bit of this. Just so if you guys decide to start your homework.
Well, I'm.
So play with that more if you decide to. Up to you. So, circles are really sweet when we go to graph them. And the equation for them is really, really cool. It's one of those, like, when you understand how it works, it's kind of got a beauty to it. Because when we think about squaring values, what's one of the interesting things about when we square integers? You think about the range of what happens, and when you think about a parabola. Because when we think about squaring numbers, this all comes back to a parabola. because a parabola is just a representation of my input values squared get my output values. So this is just representing your squares.
Set of all square values.
What's interesting about them? Or what's like one of the relationships that makes them easy to work with? Or and think about integers versus whole numbers. Why did I say integers instead of wholes?
Square and negative.
What about it?
It makes the same as the positive.
I end up spitting out identical outputs when I put in opposite values. So whether what I add to here becomes a negative 3, 4, 5, whatever number, or a positive 3, 4, 5, whatever number, you're going to get the same output. So that creates some interesting situations when you go to graph this, because we're graphing when I have an input for x and an input for y, or sorry, an input for like the x and the h related to the x and the k related to the y. So if I just want to graph a circle, so grab your TI-83, we aren't going to shift it at all. We're going to be at the vertex, which means that all I'm going to have is x squared plus y squared equals r squared. So what you need to decide is how big is your circle going to be, and then how I would be able to type that in to graph it. Well, I can't really type in x squared plus y squared in my calculator because it wants a y equals. Numbers.
What?
Exactly. Did you say like?
I said you could take the square root of it, but I don't know
Okay.
if it would work. Or if it would even graph the
Will you repeat what you said? Like the object.
So we want to be able to put this into our calculator, right? We want the calculator to be able to graph circles now. And actually, there's a little activity where we can make it graph a smiley face. So what we want to do is get to a point where we know what y equals. So this process goes through how to do that when we have an h and a k, when we've had a horizontal shift and a vertical shift. But let's, before we get to this, talk about what would happen if we didn't have a horizontal shift or a vertical shift. We're at the origin, we choose a radius. How can I type that in my calculator? Well, if I come over here and I try to isolate this, well, if there's no h and there's no k, what I really have is x squared plus y squared equals, what do you want a radius to be? 5?
17.
So let's make it fit on the standard.
25.
4.
So 4, let's do, because we have squares involved, let's go ahead and do 4.
Yes!
See if that makes life easy. So that'd be 4 squared. So that'd really give me, and you can write this wherever, but this does not relate to that problem. It'd really give me x squared plus y squared equals 16. And if I start to work to isolate the y squared equals 16 minus x squared. What's up?
On the calculator. How do you type R?
No, you just set lines where you want.
Oh yeah.
Let's use lateral numbers.
So it's going to be square root of 16 minus x squared, but then
Y equals 4 minus.
That would be a circle.
I was good at it.
is that how this works?
Oh, yeah, I do calculator. Why
Because it's like parentheses and then the square root of the parentheses. So you can't take the square root of the individual 16 and the x. You have to
Unless
take
they're
it
Leave it
together.
right here.
That's
Just leave it there. You don't need to take the square root. The calculator can deal with that. So just type in your y equals menu, radical 16 minus your x squared.
It doesn't work.
You mean it doesn't work?
It worked. No, it didn't. It only has to.
Now here's the problem when you go to graph this. Your y's and your x's do not actually take up the same amount of space on your calculator. Because if you actually compare the space between the vertical jumps to be 1 and the horizontal jumps to be 1, they're not even. They're not the same amount of pixels.
Oh, because your window.
And
We gotta add
I know. Why do we only have a half circle?
So much
Make
cuter
a
than
half
mine.
circle and then the other
How do I make the other half circle?
by taking another half parabola thing like that.
Oh, there.
It's being a negative.
Ooh, so try. What if we type in the same function but a negative form of it, or the opposite of radical 16 minus x squared?
Is there a way to copy and paste it calculators?
Maybe.
Would you tell me?
No, just like the negative of radical 16 minus x squared.
It does not look like that sort of does, but I feel like the line.
Yeah, it looks like an oval, but what we really have is a circle, just because the scale of my window is off.
Wait, but my scale is 1 to 1 is -10.
But the pixel size isn't the, so here's what I'm trying to say why it looks wrong. The vertical change to go 1 is a certain amount of pixels. The horizontal change to go 1 is more pixels because the screen ratio size of like
We
9 to
should just make it a
16.
square so that wouldn't happen.
But we don't have square screens. You can change the settings in your calculator to make the screen square. If you square out.
Why don't they just have?
I think it's in the zoom menu.
Yeah.
It's not zoom square.
It's
That is if you want to zoom a square.
No, it is.
No, that it is zoom square.
Yeah.
Let me see.
There's another way that we can do.
Oh yeah, he's right actually.
Yeah, it's square.
Ew.
Yeah, he's right. If you hit zoom square, it makes it
That's what it does.
Look how cute mine is.
Yeah, sir, I'm confusing Z square and Z box. Yeah, so Z square. Sorry, I was thinking about Z box. Z square. Z box. Z square. If you go hit that in your zoom menu, will make this look a lot more
Oh no.
Like-
How cute mine is.
also like it should look pretty perfect. Yeah.
Why is there a gap?
We will pick that up tomorrow.
No.
That is perfect timing.
The farther you zoom out, the more
So, if you want to start playing with this, here's the homework. You do not need to get it done tonight because this is all we're doing tomorrow, this circle stuff. But if you want to start playing with it,
have I told you about the names I'm gonna name my kids?
Circle? I thought you were looking to
No.
have kids.
There's Armageddon. There's Parabola.
who's
There's Exponential. And there's Deborah.
okay.
And Deborah. And Deborah.
I thought you were looking to have kids.
You're another.
Have a great day, guys.
I think you need to have a more positive attitude.